Hello and welcome to this second installment of setting up our subsystem for RTS selection. In this part we're going to continue where we left off, implementing our camera plugin, finish up implementing all the inputs, and we'll create an interface for our inputs to talk to our project. In particular, a player controller from our project. We'll create that player controller class and then implement that input interface, and we'll get a reference to our subsystem, and then we should be ready to start implementing our subsystem after that. So in here, we need to assign some default values to our target location, rotation, and zoom. We'll need to use the camera component here and making sure that's not null. I don't want that. And again, we're just going to check that our input data, because we're going to be referencing that, is valid. I don't know what AI is trying to give me there. But the first thing we want to do is the location. So we're going to get a start location, and we're just going to use the actor's location. So wherever the pawn is placed in the world at the start, and we've taken possession of it, wherever it is, we're just going to get that, and then we're going to snap that location to the terrain. So whether you're using a terrain or not, the floor is basically what we're talking about here. So we're going to just run that through there. So if we happen to just place the pawn in the world and it's not sitting on the ground when the map starts, we just want it to snap to the terrain, the base of it. So now that we've got that start location, it may be the same position that we're in right now, but it might not. But what we're going to do is we're going to set the actor location to this new location, whatever the output is from our terrain. We'll do that terrain function in a second. And then the target location, we're going to update to our current position. So now let's just do that terrain thing quickly. It's just a quick raycast or line trace. So we're going to need hopefully AI will just give us this. Pop this a million times, this function. Not going to give it to me. All right. And then we need to offset the origin up in the air by a certain amount so we can cast back down to the ground. So we're going to add that amount actually. I'm going to add an extra 0 in there, I think. That looks too many. No, that'll do. It'll depend on how undulating your terrain is. If you're using the value you want there, might be something worth putting in a setting. And this one's going to be minus equals the same amount. So we're hopefully encapsulating the terrain in between those two positions. All right, so let's do the trace. So get world. And we only need a single, so line trace single by channel. That's our hit. I can't believe AI is not giving me this, but anyway. Trace and visibility. I'll do. Now, if your terrain's on a custom channel, you'll need to change that. I'm going to leave that on visibility for the time being. Don't have any collision params, so that's default's fine. And then, because we're just tracing straight down from our current position, we don't need to worry about the position changing. It'll just be the Z value that is modified, so we can just pass back the entire hit location. Like, we don't need to extract the height and remake a vector or whatever. So that's that. So that's our location done. Let's do our zoom. Zoomness. So it looks like it's going to give us our target zoom there. Let's have a look. Input data, start zoom. I'm not sure what this is. Select that out. There we go. That's our zoom. And then for rotation, I'm going to create a rotator. We need to include the uCamera component.h. So we're getting the rotation of the camera. I'm going to add in here, so like a pitch when you zoom. So as you zoom in, the camera will tilt more to a horizontal level rather than just be straight in and down. So what we're going to want is like a zoom ratio. So need a float. And to get that, oh, there we go, it's going to give it to us. So that we're just going to generate a zoom ratio based on the min and max zoom. And what is it? Got a comma. And then, well, we're going to need that. We're going to need a target pitch. So that'll be that pitch. So pitch is that, you know, leveling out based on the zoom ratio. So yeah, that's okay. But we need this. We're going to just adjust this, the lerp amount. So I'm going to do a float. That's adjusted. There we go. And we'll need that in the input data. I'm going to come in here. Where's our pitch stuff? I'm just going to duplicate this max pitch and put in a pitch angle transition. All right. And then this adjusted zoom ratio will go into here. And then, so yeah, I'm sort of doing, it's technically rotation, right, pitch? And then target rotation will be our target pitch is so we're creating a custom rotator here from our pitch and our rotation. All right. And I think the other thing we want to do in here is we can do it outside that because it's going to happen all the time. We want our modify key types. We just want to create that as a new struct. So it's empty and they're all values are false. And we're going to set that, we had the Boolean for is initialized. We're just going to set that to true. And that'll, actually we might as well use that now. It's just going to allow the tick to kick off really. So the update, if initialized, actually no, sorry, not that. That's the actual, what we're going to call in tick here. We're just going to go if initialized update. So we'll start updating on tick. Yeah, once delta time. Since we're here, might as well do our update function next. So let's do, we want this same check here in the update function. So we're going to do movement first. Oh, sorry, it's not movement. Well, it is movement, but it's location. And then zoom and rotation. So in the location, again, we'll just get that come up, did it? Yeah, current location, get the current location. And then we want to interpolate the current location to the target location using that smoothing value from our data. That's the x-axis. Do the same for our y-axis. There it goes. We'll create a vector out of those interpolated values. We'll actually we don't need to neutralize the 0. We can the z-axis, we can just run it through our get terrain position. So at our new location, we just want to adjust the height basically, and then set the actor to that new location, and it's moved on that tick. So now for our zoom, we want to get the camera location. We want to calculate a desired zoom, so it's going to be the target zoom, but yeah, we're just clamping it to the min and max zoom. So we're interpolating from our current camera Z position to our desired max zoom value, and then we just want to set the location of the camera now to that new position. So the XY is not going to change, but that Z value will be that interpolated zoom. So that's zoom, and then rotation. We are just going to interpolate our camera rotation to our new target rotation that's coming through, and we'll be doing these in a sec. But and then we want to set the camera rotation to that new interpolated rotation. So that's the actual movement based on the values that we are setting when we press keys. So we need to do the key presses now. Oh, hang on, let's do this input mode since we're here as well. So input mode is just setting like the, whether you can see the cursor, whether the, the screen locks the cursor and all that sort of stuff. So we need a player controller for that, and it's just a generic player controller. There we go. I want any of this. Show cursor's fine. One other thing I want to do is reset the input subsystem. So we need to, the enhanced input mapping, we need to reset that. So we need the enhanced input subsystem. Enhanced input, I think it's player, local player subsystem. Yeah, that's the one. So that's included a H at the top. Don't need all this. Input subsystem, and we get that from local player. And then, what's all this? We do need this. Actually, no, I don't need any of that. So all I want to do here is just remove the, so on the input subsystem, we just want to clear all mappings. So basically unbinding every key there is assigned, and then, we don't need that twice. And then in here we can also do our input mode. So there's a struct for that, and we're going to do input mode kmin UI, and then there's a setting in here. Yep, to hide cursor during capture, so that like makes the cursor disappear when you press it. I don't want that. And then because we're going to be potentially debugging multiple windows, I'm going to set it to the lock mouse to viewport behavior to not lock. So you can sort of move the mouse between windows. It's not going to capture the mouse in the window. And then we use our player controller reference to set that input mode, and there's actually a function for this. That's that. And then we just need to make sure that this occurs after before we set our input mappings. I think this can be constant, right? Fine. Yeah, so we're setting the input mode, which resets the keys and stuff, and then we're going to set the default input mode. So we do that here, and we need to do the same. Let's just grab this. So input data is valid. We also want to check if the input data default mapping context is assigned. And then, yeah, I think that's right. What do we call? That should have been default. Oh, that's right, map priority default. That's cool. So that'll be, probably 0, the lowest priority being the default. All right, so that's our default mapping done. Where are we up to? I think we're up to doing our inputs. So actually, before we go on to inputs, we need to decide how we're going to talk to, well, one, our selection subsystem and our game in general. So, I mean, input, zoom, and rotate, they don't need to talk to anything. They're all going to operate just in this class. But when we get to input select, then we're going to need to talk to our selection subsystem, for example, and there may be other things you want to do as well. So what I'm going to do for this setup is I'm going to point all these to a interface. So that interface can be implemented wherever you like. I could go directly to the subsystem here, but I don't want to really have this plugin be dependent on this module, for example. We could move the selection subsystem into this plugin. That's an option, and you could just go straight to the subsystem, but I want to keep them separate. So, like if I just want some movement and I don't want to use a selection subsystem, then this will just work generically, and this interface that we're going to create now, you can just implement that on any player controller and implement things how you want. So there's a few different setups there, but this is the one we're going to do. So in our camera plugin, we're going to add an interface, and we're going to just call it RC input interface, and just in the public. And I'm going to move this API to here, so when we implement this interface outside of this plugin, we can still access it. All right, so in here, we'll need our select functions. So, there we go. Look at that. This is exactly what we need. Oh, we don't need the preview. That was for something else I was doing. But so we've got let's just bring these in. So we've got the are the select and the command functions. So they're the ones that are going to be external to our class. This is going to need a forward declaration. And we're just doing equals 0, so it means there's no default implementation. So when you implement this interface, it means that these will need to be defined. So let's go back to our pawn now and start doing these inputs. Start with the internal ones, which don't use that interface, by the way, but we'll get there. So input movement. Yeah, we're going to check that the input data and the... So we've got one that's got both already. Let's copy that. So the camera component and the input data are valid. And I might actually just do is equal and or equal to null. So if either of them are null, I'll just return. Saves us having a if statement there, if brackets. And then to ensure that the input move is set up correctly and it's going to give us the correct values, we need to ensure that it's got it's the right type of input action data that's coming in. So the input action value and the value type is equal to this is a 2D from memory. I'll come up and I missed it. All right. So for the movement, that's the 2D. So you've got two values ranging from +1 to -1 forward and back, and the other value is +1 to -1 left to right, which makes up your movement. And then there we go. What's this? I'm going to reduce the movement speed based on the zoom. So I'm going to add a float here for zoom ratio, similar to how we did it before. It's going to give it to me. So that's a zoom ratio there. Tells us how far along the zoom we are. And I want another float for the base speed to go off. So this is going to factor in the modifiers. For this case, I'm just going to hard code if the modifier key shift, then we want to increase the base speed, right? So the move speed is going to be affected by that input multiplier. Otherwise, it's just the normal speed. So now we have that base speed. We can calculate a speed based on that zoom ratio. So now, because the camera is going to be rotating around, we need to get the correct vectors. So let's just get the camera rotation. And the forward vector of the camera. That was meant to be an F vector. Many Fs. The x-axis and there it goes, right vector. And now we can calculate the target location. So target location will be the current target. Oh, there it goes. Target location plus the input. This in, have a look. That's correct. Yep. So forward vector plus the x value. So plus the forward amount basically, and the right vector plus the left-right amount, and then multiplied by the speed will give us how far we've moved in this tick. And I'm going to change this to plus equals. Get rid of this. And that is our target location. So on to zoom. I don't think we need the camera here, so we'll just use this one. I'll do the same. So again, we just want to check the correct values coming through so we don't get any crazy results. And this is actually a 1D, not a 2D for this one. Again, we want to affect the zoom speed by the ratio. So similar to what we did up here with the shift key. So I might just copy this. And then it'll be the zoom speed by the multiplier. Otherwise, it's just the normal zoom speed. And then our target zoom. So we don't need to worry about pitch or anything like that because it's going to be handled in the update function. We just want to set the target zoom to whatever height it's at for this. Yeah, we want to clamp the zoom. That looks all correct. So we're adding the input amount plus the speed, and we're clamping it to the min and max zoom. So that's our target zoom done. And then for our rotation, we want this again. And it's going to be a 1D as well, so copy this. Probably could put these. You could put this in here on the one line, just change that to a not equals, but okay. Again, we want to modify the speed based on the handler, so the modifier, not the handler. And so the rotation speed by the modifier, otherwise it's normal rotator. It's getting pretty similar now, isn't it? And then we could calculate it on a new line like this, I guess. Either or, and then the target rotation. I'm just gonna, oops. So we're getting the pitch that we currently have and putting that in and then adding the new rotation to the yaw, so the left and right as we rotate around. And I'm just gonna, what about 0.2? I think I found that limiting the speed of the rotation is a bit better, so that's why it's got a times 0.25 there. So I'm just going to move this into here. And so I've done all the others in line. Get rid of that. Right, on to select. So this is where we're going to use our interface. What do we call it? It was RC or, yeah, oh there it is, RC input interface. So we're going to include the RC input interface.h at the top, and we're going to get a reference. Not sure where that's getting that reference from. That's not what we want. We actually want it to be, it's going to be implemented on a controller, so a player controller. So yeah, there we go, get controller. And then I think it was called select. Yep. We're not passing any value. We're just calling select. It's not an analog value. It's just an on or off, so we don't need to pass the value. All right. So this setup here is pretty much going to be the same for all of these, except we're calling a different function. So command and then even down to our little to do here for this. So let's now update these. So this is going to be select hold, select end. This will be command, hold and end. And then this one was it update modifier or set modifier? Set modifier, there we go. And this one takes the modifier key that we're sending the value across. All right, so that's all our inputs done. And it can talk to anything now wherever we implement this. Like it's obviously set up to be implemented on a controller though, just keep that in mind. All right, so now we need to inherit this interface somewhere so we can talk to it. And there are probably a number of ways you could do this, but the ideal way would be to go to your source project, wherever you're, so not in a plugin, not in a module, and use your player controller there. If we, for example, created a player controller in our selection module that, handles talking to the subsystem, you're going to get a dependency from our rogue selection module to our rogue camera plugin, because we'll need to inherit this interface. So what we want to do is have it in the rogue systems here, or whatever your project's called, in your generic, let's just call it your source project, right? Whatever you called the project when you created it. And then that way all references to plugins or modules go to here, and there's no dependencies between modules and plugins. So our player controller is only, it needs to talk to the rogue camera plugin and needs to talk to the rogue selection module. These two don't really want to talk to each other, and that's how we do it, by having this central thing. The alternative is to have, and I've done it in the framework, you have like a core plugin which handles all those cross-reference dependencies and has interfaces to talk for everything to talk to everything. But yeah, that's, so we can just have it in the project for this case. But so we're just going to create a player controller. I'll call it RS player control. I'm going to put it in the framework player. Going to create the constructor. Alright, so that's the player controller set up. Now we need to inherit that interface. Or I should say implement that interface.
And this is going to need a reference to the plugin, so it's going to be, was it input interface? Finds it, does. There you go, so it needs the RC input interface.h included, and it also needs the Rogue camera plugin in the build.cs, like so. And pretty sure if we come down to Rogue Systems U project, we need to add the plugin here as well. So we just need to add this. And this would be, is it Rogue camera? That will stop you getting a warning when you build. Close that. Now this will take a little minute to do its thing, and then we should be able to implement those functions that were from the interface. There it goes. So I'm just, with a shortcut here, you can generate the missing things. So it's going to pick up that there's functions missing here. It's going to say, okay, these are what I've found that needs to be implemented, because we don't have a that equals 0 is not implemented. And then we can override those functions. So now we need to implement the begin play here. So let's put that in. I'll move that up. So on begin play, we want to assign our subsystem a reference to it. So actually, let's just create a variable for it here. That'll give us the, I don't want that. We want the Rogue selection subsystem and add our forward declaration for that. And then our selection subsystem, actually, we need to check first that, well, if it's not local controller or the local player is a null pointer, then we don't want to do this, but the selection subsystem will be get local player, get subsystem, and of our type, and then we've got a reference to our subsystem now. This wants this to be assigned. There you go. So now when we call the select, we can do the same here. Actually, I should add in or subsystem. It's a null pointer. So if that's all good, then we can. And the reason why we're doing the local controller is the get local player is where the subsystem lives. So we don't, if it's the server executing any of these things for somehow, then we don't want to call things on the subsystem because it won't have a reference to it. All right, so we don't, well, this is, so then on our subsystem, let's bring it up stuff, but so we're going to have functions on there that's going to handle things. So you can see it's picking up what I haven't even created yet, but it's start selection, and there you go. It's going to pass through the modifier as input. Yeah, so we'll need an input modifier key reference because it's coming in here. So probably don't even need to implement that function. It's gonna do it in line. Come back over to here. Just get rid of this. And we're just gonna set it. So we're just gonna have a property for it. There we go. That's setting what the modifier key is. And then in the select where we want to pass it here, we need to cast it to an int because we don't, the selection subsystem isn't going to know what this enum is. So by passing it as a int, that should do the job. So I think we're at the point now where we can start
Yeah, so I think we're at the point now where we can start setting up our subsystem. So I'm going to break this video here and we'll come back and we'll start implementing our selection subsystem. If you're finding these videos helpful, give us a like or a subscribe. The project files are going to be available on Patreon. You can become a member there and get access to other projects and keep up to date with my game development updates and support this channel. Thanks for watching, and I'll see you in the next video.